In this video, we're computing the trigonometric integral cosine squared x plus sine cubed x dx. And the key to this integral is realizing that I can get a lonely factor of sine next to a bunch of cosines. That's going to give us a differential that allows us to integrate those cosines. So the basic idea here is to take that sine cubed x and split off a sine squared, which we can then transform in terms of cosines. So I have the integral of cosine squared x, sine squared x times sine x dx. And I realize that I can rewrite sine squared x as 1 minus cosine squared x. And again, the reason I see that this is a promising approach to the problem is that we're going to be left over with this single factor of sine x, which is essentially the derivative of cosine within a minus sign. That's going to give us the derivative of the interior function on the leftover terms so that we can integrate either by using a u-substitution or the chain rule backwards. So now I can write this as the integral of cosine squared x times 1 minus cosine squared x. There I've just applied the basic Pythagorean identity, sine squared plus cosine squared is equal to 1. And we can distribute the cosine squared into these parentheses, and we end up with a cosine squared x minus cosine to the fourth x times sine x dx. Now at this point, you could make an explicit u substitution and say let u equal cosine x, and that's only going to work because you have the derivative of that interior function u sitting right here. Again, you're going to have to adjust with a minus sign, but that's essentially the derivative of the interior function. I prefer to look at this from the perspective of just building the chain rule backwards. So to make this extra clear, I'm actually going to build the derivative of the cosine function into this integral. It's not exactly the sine function, it's negative of the sine function. So what I'm going to do is multiply my first term by -1, and that creates a positive cosine to the fourth x minus cosine squared x. And then I have this derivative of the interior function here, negative sine x. So I multiplied that by -1 as well, and then dx. So when I have the derivative of the interior function sitting next to a function composition, the chain rule has been taken care of because the chain rule, what it does is tack on the derivative of the interior function. This allows us to naively integrate these two powers of cosine with the simple power function formula. In other words, cosine to the fourth times negative sine x is going to integrate to a 1/5 cosine to the fifth, and cosine squared is going to integrate to 1/3 cosine cubed, and we tack on a plus c for this indefinite integral, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.